Okay, welcome. This is Mr. Francois. Today we're going to be talking about how to correctly identify series and parallel. Now, if we have a basic circuit like so, where we have but a single light bulb, we don't need to describe this as being either series or parallel. Now, if to correctly identify what is in this image, this diagram that I've drawn for you, this right here is the symbol for a battery. The shorter side here being the negative side, and the longer side here being the positive side. And our circle with an L in it represents our light bulb. So we have a light bulb simply connected to our power source. It could be a battery, it could be a outlet in the wall. They're all symbolized by a battery symbol. Now, I cannot describe this as being in series or parallel with the battery, because there's only one way to hook it up. I mean, it's, direct line straight to it, right? And back to the other one. However, if I add in another component, so let's put another light bulb right here. This is what we call series, because all of the electrons, that flow out of the negative terminal flow into this light bulb, which I'll call light bulb A, just so that we can know what we're talking about, and this light bulb we'll call light bulb B. But all of the electrons that flow into light bulb A must flow out into light bulb B. There's no other option for them. This is what makes series, because it is a direct link. Everything must go through one to get to the other. And everything that goes into one must come from the other. So the only way to recognize this is that all of the electrons must go to the next one, and they have absolutely no choice about it. Now, if we wanted to create something in parallel instead, so let me go back and take back our little circuit here. If I wanted to create something in parallel, what we would do is we would add in another light bulb, but this time we're giving the electrons the choice. So when the electrons come out of our negative lead there, we give them the choice. They can either go to light bulb A, or they can go to light bulb B, but they cannot go to both. So our electrons could go this way, or our electrons could go this way, but they cannot go both ways. It's like water rushing through a pipe. When it comes to a split, the water will go both directions, but it's not going to come back and circle around. This is not correct. So, this is parallel when all of the electrons go through either one or the other. Now, we can have multiple things in parallel. It's not a problem to have multiple things like so. And there's an interesting thing here. Even though, we can recognize this is parallel, this is the exact same as if I had done the following. If I attach the wires up here, there's no problem with it. You can move the wires wherever you want to. You could have attached them here, you could have attached them here, you could have attached it here, as long as you don't move it over a component, or move it onto a different branch. So our line here that we connected in could have even been moved up here somewhere, and it would still be the same thing. Our light bulb would still be connecting back to what I call the main line, and this is what I mean by the main line right here, highlighted in blue. The main line is where all of the electrons flow. They have no other choice. They must be on that main line. Now, obviously, if I make my connection up here, this section of the main line right here is no longer part of the main line because I have connected to it up above. This is Mr. Francois signing off.